Non-ideal solution. When a solution does not obey Rowlett's law over entire range of concentration, then it is called a non-ideal solution. The vapor pressure of such a solution is higher or lower than predicted by Rowlett's law. If it is higher, the solution exhibits positive deviation. If it is lower, it exhibits negative deviation from Rowlett's law. Now we are going to see the mixture which exhibits positive deviation and which shows the negative deviation. Non-ideal solution, positive deviation. In the case of positive deviation, the enthalpy of mixing the two components is greater than 0. In the case of positive deviation, the enthalpy of mixing is greater than 0 and the volume change for the mixing also greater than 0. The partial pressure for the positive deviation greater than the partial pressure of A greater than the partial pressure of the pure component. The partial pressure of B is greater than the partial pressure of the pure component. Now for example, consider ethyl alcohol and acetone. Component 1 ethyl alcohol and component 2 acetone, or component A ethyl alcohol and acetone. There is due to the electronegative difference between the oxygen and hydrogen, there is a hydrogen bond present between two ethyl alcohol molecules. So the bond is stronger in the case of ethyl alcohol molecule, component A. Now we are adding acetone to the ethyl alcohol. The acetone, the electronegative oxygen present in the acetone disturbs the hydrogen bond present in the ethyl alcohol. It makes it weaker. So after mixing the two components, ethyl alcohol and acetone, the attractive force present between the two components become weaker. Thereby, due to interatomic force is weaker, they are easily evaporatable. So they are easily evaporatable. So the vapor pressure is higher. So it shows higher vapor pressure. So here the explanation is given. Ethanol and acetone, pure ethanol molecule hydrogen bond, and adding acetone to them, it will break up some hydrogen bond due to the weakening of interaction, the positive deviation from the Rowlett's law. So this one is the expected, this one is the component 1 and here component 1 and component 2. Here the expected vapor pressure, the linear one, and here it shows the positive deviation. And similarly here the expected one for the second one, and it shows the positive deviation. So on mixing the both component, there's change in the vapor pressure. At the end it shows somewhat higher vapor pressure. After mixing it shows somewhat higher interaction. Thereby the vapor pressure, due to the interaction, the vapor pressure increases. The next one is, so the mixing, the similar case also explained for adding carbon disulfide with the acetone. Similarly, the positive deviation example, carbon disulfide with acetone, the dipole interaction between the solute and the solvent molecule, weaker the respective interaction among the solute and the solvent, and the solution shows positive deviation. The solution shows positive deviation as the attraction between the molecules, component A and B, decreases due to mixing. The vapors are in the molecules easily evaporatable due to the less interaction, and it shows the positive deviation, that is a higher the vapor pressure than the expected one. Now in the case of the negative deviation from the Rowlett's law, negative deviation, the enthalpy of mixing the two component is less than 0 and the volume change for the mixing the two component is also less than 0. So the component 1 and 2, it is lesser than that of the expected one, the lesser than that of the expected one. Here in this case, the vapor pressure is less than that of the vapor pressure of the pure component. Vapor pressure of the B also less than that of the pure component. Here what it is given as a example is, now we consider the addition of acetone to the chloroform. Here the acetone, due to the change in the polarity, here there is attractive force present between the chloroform and the acetone also, that acetone CH3CO and here CHCl3. Now when we mix acetone with the chloroform, due to the electronegative difference between the acetone oxygen atom and hydrogen of chloroform, there is a strong attractive force formed between the oxygen atom and chloroform. So due to the attraction, the molecules do not, there is a decrease in the escaping tendency of the molecule for the component. So as the escaping tendency of the molecule is decreased, the vapor pressure also decreased. So in the case of the decrease in the vapor pressure or negative deviation due to the interatomic attractive force between the component A and B increases, the vapor pressure also increases than the expected one. So thereby the negative deviation in the case of the non-ideal solution. So positive deviation and a negative deviation is explained. For positive deviation, mixture of ethyl alcohol and acetone, mixture of ethyl alcohol and carbon disulfide. And here for the negative deviation, acetone and chloroform is explained. And the one more explanation is the mixture of phenol and aniline. When we mix the phenol and aniline, in the case of negative deviation, the attractive force present between the phenol hydrogen and the lone pair of electron present in the nitrogen becomes much stronger. So on mixing phenol and aniline, in the interatomic force is more, thereby the evaporation of molecule get decreases and the vapor pressure also decreases. That is example of negative deviation. Ethyl alcohol and acetone, ethyl alcohol and carbon disulfide for positive deviation, non-ideal solution. Phenol and aniline, acetone and chloroform is example of negative deviation. Subscribe for more videos. Thank you.